Now we want to define trigonometric functions on the unit circle. So this really puts our unit circle to use, so we can think about why we have been, working hard to fill in the angles in degrees and radians and the marked points. So if the point xy is specified by the angle t on the circumference of the unit circle, then x equals cosine t and y equals sine t. So let's draw a unit circle. So I'm just drawing a circle centered at the origin with a radius of 1. And let's draw an angle t in standard position. And it doesn't matter where we draw it. So let's say it's down here in the third quadrant. And then there is some point here on its terminal side, but of course also on the unit circle, which is kind of the point, important part. And so what we can say is that these values here is the x coordinate is equal to cosine t, and the y coordinate is equal to sine of t. And so this is kind of amazing because it can give us cosine and sine values for any angle t. And so before, when we were doing, let's compare what we had before, we were using right triangle trigonometry. Right triangle trigonometry leaves us just kind of in the first quadrant, thinking about angles that are less than 90 degrees, because I'm stuck in a right triangle where one of the angles is already 90 degrees. So the two other angles are have to be smaller than 90 degrees. So we're kind of stuck in that first quadrant. But with the unit circle, we can define cosine t and sine t for angles that are bigger than 90 degrees. But with this kind of new definition, we want to make sure that it still works with the right triangle trig that we learned before, right? In math, we want everything we've learned before to kind of like still hold. So let's look at that. So let's look at the unit circle again. So I'm just drawing a unit circle. And so if I have some point, because I'm using right triangle trig, I have to keep my angle kind of in the first quadrant here. And so this point here, I'm going to call x and y. So if I draw a right triangle, okay, then if that point is xy, then the length of the short leg is x, and the length of this longer leg we'll call y. I know the length of the hypotenuse is 1 because we are on the unit circle, and the radius is 1 on the unit circle. So if this angle, starting in standard position, of course, we'll call it, say t, just to match what we have above. Then let's just use right triangle trig to see what we have. So if I used cosine t, I would have cosine of t. Well, let's mark our sides. So in reference to the angle t, this would be the adjacent side. This is the opposite side to angle t, and of course the hypotenuse is always just the hypotenuse. So if we do that, we have cosine of t is adjacent over hypotenuse. So again, now we are in SOHCAHTOA land because we're in a right triangle. Okay, so cosine of t is x over 1, which is just x, and sine of t would be opposite over hypotenuse, so y over 1, which is just y. And so we notice that having cosine of t is equal to x is just what we have up here, and sine of t is equal to y, just matches what we have up here. So all we're really doing with this unit circle is kind of expanding our definitions for cosine and sine and being able to find those values for angles larger than 90 degrees. So let's practice evaluating some expressions using the unit circle. So sine of 270 degrees. So you can have a completed unit circle, to use when you're practicing, but I think the best way to learn the unit circle is by kind of recreating it every time. Now, do we need to create that whole thing? No, but we can certainly just draw a unit circle. So under my work here, I'm going to draw a circle, and I'm thinking about the unit circle. So I have a radius of 1, and I want to think about where is the angle 270 degrees. I go, well, I know, like, if this is 90 and this is 180, then this has to be the 270. So I kind of remind myself, I go, okay, this angle here is the 270. And then the point here, right, the whole, let's kind of remember that if this is 270 degrees here, then this point is cosine of 270, sine of 270. Okay, but I know what that point is on the unit circle, right? I know that this is, if I said, hey, what's this point? We'd say, oh, that's just 0, -1. And so what I'm finding here is that sine of 270 has to be equal to -1, because just by definition, that's where it is. So sine of 270 has to be -1. All right, so let's keep going with this. Maybe we'll move this up a little bit so it's not totally in the way of everything else. Okay, let's look at cosine of 7 pi over 6. So again, I just want to draw a little unit circle. Oops, let's try to put it down the middle. Here's my unit circle. I need to find 7 pi over 6. Well, 7 pi over 6, that is bigger than pi, right? So, and I know, like I'm starting to be more familiar with kind of what are the markings on my unit circle. If this angle wasn't one that was on the unit circle, we could still use the calculator, but right now we're trying to like use the unit circle to figure that out. And so I know that like the main diagonal ones, so the ones that are the main diagonal, those ones are some amount of pi over 4. So like pi over 4, 3 pi over 4, 5 pi over 4, etc. So we don't have that, but it looks like we have a little sixth amount. Okay, so where were those sixths? And so we'll get better at doing that, but we'll say this is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Right here is 7 pi over 6. Okay. So what point corresponds to that angle? Well, the point there, it's the longest way out that I have, right? Besides just being right at the right at the very left on the x-axis, but besides that, it's like not the farthest one out. So this is -√3 over 2. And then it's the shortest distance down that I have, and so that's going to be -1/2. Okay, and since I'm asking about cosine, this is going to be equal to the x-coordinate, so this is -√3 over 2. All right, let's look at cosine of 45 degrees. This one might be even easier. So here's my circle. 45 degrees is right here. I know the point here is √2 over 2, comma √2 over 2. Cosine corresponds to the x-coordinate, so this is √2 over 2. Last is sine of pi over 3, another unit circle. Pi over 3, you know, if we're thinking of the unit circle, we have like that main diagonal in the middle and then the kind of like 2 next to it. Pi over 3 is the biggest chunk, right? Pi over 6 would be right here, but we want pi over 3 there, okay? And again, these will just get easier as you use it more, but you really have to use it and kind of recreate it every time to really kind of get it in your brain here. Okay, so sine of pi over 3. So what's our point here? So the way I remember it is √2 over 2, those are the ones for the main diagonals. And so the other ones must be, you know, for what I have left. So for this one, I'm going over a short amount and then up a big amount. So the short amount is 1/2 and the big amount is the √3 over 2. Okay, and this is asking for sine, so my answer must be the y value.